These are the machine learning and prediction modeling seminars that are hosted by the prediction modeling group at the Biostats and Health Informatics Department at King's College London. So I'm Raquel Iniesta. I'm a senior lecturer in statistical learning for precision medicine here at the Biostats Department. And we host these meetings monthly. So every last Wednesday of the month, we have a meeting in machine learning and prediction modeling from 3 to 4. And today there was the coincidence that today, exactly the 24th of May, is the starting of the King's Festival of Artificial Intelligence. And this is why today is a very special day, because today we are not in the office or in our home presenting this talk, but we are in person in the exhibition, because there are two events happening at the same time, which is quite interesting. There is the exhibition Bringing the Human to the Artificial, which is commissioned by the King's Institute of Artificial Intelligence, and it's extremely interesting. You can come to the Bush House at the Strand campus, and you will be able to see many interesting work that is being done by researchers here at King's on the application of AI technologies. So, for example, well, you can see the first one is mine. Sorry about that. This is about the ethics of AI-based medical tools. I'll be talking about this in a minute. But as you walk for the exhibition, you can see many other works. And you can even meet some friends like Pepper, for example. If you come from 4 to 6, you'll be able to have a conversation with him, because as an event, a starting event, opening event of the King's Festival, today there will be a demonstration from 4 to 6 of different AI technologies here at the Bush House at the Strand. So you are all welcome to join us. And we are especially happy because these talks have been included in the program and the opening events of the festival today. So thanks very much to the organization for this. And we will be also giving a demonstration about how we might be reflecting about the ethics of AI in medicine from 4 to 6. So you are also invited to come here in person and see that demonstration. So having said that, today I'm the speaker, so I have talked too much, I think, already. I'm gonna leave the word to my line manager, actually, colleague Daniel Stoll, who will be introducing me today. Thanks very much, Daniel, for this.
So thanks, Raquel. I think you already did my job to introduce yourself. So I think I don't have to repeat everything, but so Raquel is presenting today in the BRC prediction modeling seminar group about machine learning and prediction modeling. And Raquel is a senior lecturer in statistical learning for personalized medicine. And she's interested in topological data analysis to apply it in precision modeling. And as you can see now in this talk, she's also very interested in fair modeling and how AI can be used in a fair way. So her talk today is about fair modeling, a human-centered framework for an ethical development and implementation of AI models for precision medicine. And yeah, if you have got questions during the talk, please type them in the chat. I will collect them and we can ask them after Raquel's presentation. So I think that's it. So I will hand over to Raquel.
Thanks very much, Daniel. I would also like to tell people that this will be recorded. So I hope that you don't have any problem with it. So thanks very much. Thanks, Daniel, for the nice introduction. So yes, the talk today is entitled Fair Modeling, a Human-Centered Framework for an Ethical Development and Implementation of AI Models for Precision Medicine. Okay, so as you've seen, I'm giving the talk from the exhibition. So if there's any noise problem, please let me know. I can move to another corner, but there are a lot of people at the moment preparing their demonstrations here. So let me start by traveling 10 years ago. So back in time, there were many people like me, very motivated in spreading the word that a shift from traditional statistics to machine learning was really needed. So we felt that we needed to incorporate new techniques and that were able to tackle the complexity, the big challenges that the big data that was about coming was in it. The thing is that 10 years after, I think that machine learning just really crossed boundaries. I think that well, it has become the basis for precision medicine models and for the clinical decision support systems. And in some way, when I used to use this image in some conferences I went years ago, for example, in the World Congress of Psychiatric Genetics in 2015. And the idea was like that we should be that fish that is moving from traditional statistics to incorporate other models. And at the moment, there were not many fishes in the other bowl, right? I think that today that would be much different, and this would be absolutely filled of fishes, and we're already using machine learning and AI techniques in general for precision medicine. But if we go back in time again, you will agree with me that clinician's office was quite different. When the clinicians had to make a decision on what treatment to prescribe for a single patient, there was not much information available for that, but the clinician's expertise and some tools to make some measurements. So the machines, the tools that the doctor was using might be, like you can see in the picture, a stethoscope, for example, and another kind of machines that were basically allowing the doctor to make measurements. So in this funny cartoon, you can see that doctor trying to try between two drugs, and he's advising the patient to take the black one when the market is up and the red ones when the market is down. So that would be a very cost-effective choice, right, of drugs. But the thing is that as the years pass, and in the last years, we have seen the machines coming, particularly the computers coming into the doctor's office, right? But the role of the computation and the computers was just to allow for data collection. The idea was to start building what's called the electronic health record of the patient, the computerized medical history. That before, you might remember, it was just taken by writing. I have seen my doctor writing my clinical history before, and that completely changed now. The relationship was really a master-servant relationship. So the machine was there, but the machine was not making any suggestion about clinical decisions to help the doctor. So the machine was not processing information. The machine was there to collect information. So I think that currently there is a big change of paradigm. So the machine has taken a much important role. It's just not for processing, for data collection, but the machine can process information and give some information. So help the clinician make decisions. This is happening because of the emergence of the AI systems that can support clinical decisions, right? These AI-based programs can allow machines to recommend clinical outcomes, particularly based on patients' information. So, for example, imagine that this lady is presented, or this doctor is presented with that case on hypertension. Hypertension is the single largest cause of mortality worldwide. And we know that there are more than 30 treatments available to treat hypertension. And it's true that there are some guidelines on how to prescribe this, but this is like very preliminary, and many times the choice is mainly based on trial and error. That means that we try the drug and it works, we keep the drug, and if the drug doesn't work, we just change it by another one. And we test drugs until we find the one that is better fit for the patient. The difference here is that when an AI system is in place, the AI model can recommend a treatment choice. This is based on data provided by the patient, right? So, for example, in that case, it might happen that this clinician introduces in the machine the genetic background of the person, some information on family history, and obviously demographic information as well, also ethnicity. And given that information, the AI system can be able to provide a recommendation. For example, it can say, oh, the drug that will give a better response for this patient will be candesartan, for example. The kind of information that an AI system can fit with is very, very diverse. So this can be clinical information, as for example, the severity of the patient, laboratory measures, like something biological measures, from, for example, taken from your blood sample, imaging data as well from, for example, brain scans or X-rays, omics data, that omics is the word that is used to talk about biological data in a very large scale, like genomic data, proteomic data. Also, data from environmental information. For example, for the hypertensive case, it will be very interesting to know the diet that the patient is following, or for example, the exercise that she's doing, but also data from wearable devices that can be tracking you about the exercise, for example, or about how is your pattern of sleep. So given all this data that can be integrated, and this can be introduced in the AI system, and then this machine learning algorithm can be selected, the one that is better performing. You can develop the model, you can evaluate the model, and you can see how it predicts well. And you can put this model to work to prescribe in practice, to help the clinician prescribe a drug for a single patient. So what is the kind of output information we can get? So yes, we can get a treatment choice, as we've seen, also a diagnose, if you are in seek of a more accurate diagnosis, but also the systems can help doctors to warn them about possible drug adverse reactions in particular patients. All of this can enable what we currently call personalized medicine, which is basically targeting diagnosis and treatment choices to individual people. So healthcare is really one of the most promising application domains for artificial intelligence. I think that very recently we have seen how AI techniques and their applications can really help to detect cancer, and that they can detect it faster and earlier than before. They can do more accurate medical diagnosis and also treatment choices. And this is probably why governments around the world, including obviously the UK and the US, are making very big investments trying to integrate the AI systems in routine care. Two AI systems were firstly approved in 2018 in the US, few more are approved in the UK currently. For example, one of them is called the e-stroke. This is for a brain scan, and there's a software that is able to diagnose a stroke. And the developers say that they claim that the system is much quicker than a human identifying the risk of a stroke. Another application that is actually being tested across the UK at the moment is the MIA mammography intelligent assessment. And so this program can analyze standard mammograms to screen for breast cancer. And another very useful tool is the foresight, a tool that can forecast future medical events given a patient history. This has been trained in 1 million patients in the UK and is using very large language models for healthcare. So, however, even if we have a lot of potential and that this is really promising, we have seen that the incorporation of AI systems in medicine is being slower than we hoped, given the big potential. Why this is happening? So, one minute. Well, we searched from some literature about this, and we found a study that was covering about the MIA software acceptance between doctors in the UK. Even if the sample size is not very big, I think that this is still interesting to listen to the opinions of the respondents. So 87 doctors in the UK were asked about the MIA software. This is the software that I just presented to screen mammograms. And in general, doctors approved the AI system, replacing one of the initial 2 human readers, because the mammograms normally are read by 2 humans. And in this case, the idea is to replace one of them by the AI system, right? But so the respondents were happy with this idea, but they objected to the AI replacing all human readers. And in the majority, most of the doctors were preferring using national guidelines than the AI system. They claim it for the need of studies using a national representative data set. And they also claim it for the need of running independent prospective studies as the essential evidence to follow on the screen of breast cancer, of mammograms and breast cancer screening. So they also expressed some concerns and the need for additional validation of this AI tool. I think that's very interesting, and we can highlight and extract different ideas from here. So first, I think that they were pointing to some methodological limitations So they were talking about working with representative data sets. So they were not really sure that this AI system was developed using a representative data set, a diverse, a data set that was covering, for example, underrepresented groups, well, from the population. They were talking about independent prospective studies, so more studies for validation of the tool, and then reiterated about the need of additional validation. So these are all, let's say, methodological limitations of the tool. They were fearing. They were not really trusting the system because of this. There are other things that they highlighted, and when they talk about the AI replacing the humans, and they said that they were like trusting more the guidelines. So remember that guidelines are created by expert humans. So in some way they are like pointing here towards a kind of fear about the human being replaced by the AI system, right? Okay, so there are many challenges already here that we can identify. So first, I think that trust is a key word here. So are clinicians trusting the AI systems? And are clinicians trusting their developers, particularly as is the case when there is a company with a commercial interest behind? And another thing interesting that is arising from this survey, what is the role of the clinicians when there is an AI system in place? So are they fearing about the human replacement? Is really a human replacement going to be happening when these technologies are in place? But it's not only about humans, right? It's also about patients, and it's also about developers. When we saw that there were these challenges, actually, well, the thing about patients, I think that is quite similar in some ways. Also about trust. It's important that patients are aware that AI decision systems are made be made on them. Would finally patients trust these systems? What is the patient's role? And about the developers, are also the developers aware of the very important real challenges and the big impact of their models on patients' health? When I saw these challenges, I thought, oh, they really match with ethical aspects, with ethical dilemmas. When we talk about trust in AI systems, we are talking about accuracy and fairness of the predictions, of the estimations of the system. When we talk about the clinicians trusting the developers, in some way, we are talking about there's an idea of opportunism by the commercial tech companies or even misbehavior. And when we talk about human replacement, are they fearing about dehumanization of medicine? And many more questions that can be based on fears, but also have an ethical component. And these are some of the questions that during this week we have been also posting on media, and that many people have been really showing a lot of interest on this. So for example, should a clinician trust an automatic diagnose recommendation? And what would happen if a clinician disagrees with an AI automatic clinical suggestion on a treatment choice? Who will hold final responsibility on a diagnosis that has been generated by an AI system? So these questions related to the clinician, about the patients. We're talking about patients trusting the system. Do patients know their rights about an AI tool being used on them? And will ever AI tools be capable to include subjective patients' experiences in their decisions? And finally, about the development of the models, is that really a risk? As people fearing this, and there have been examples of this happening, right? Sadly. There is a risk that AI models for medical use are discriminatory, for example, by race or genders. And again, developers should be aware of all this impact. So what we did in this work, so we found that there were many ethical challenges, and there might be others that we were not aware of. So we wanted to make a systematic search of ethical challenges for an ethical use and implementation, development, implementation, and use of AI systems in medicine. On the other hand, we didn't just want to identify ethical challenges, but also to relate them to particular human agents. So the idea was to say, okay, there is this ethical challenge, but who could be proactive in taking action and trying to diminish or even avoid the ethical risk that is associated with this ethical challenge or with this situation, right? And the third thing that we considered was that if a patient-centered perspective could inform or complement this, especially given because patient-centered is really a key dimension for healthcare quality, as it has been advised by the World Health Organization. So what we did, started to look at literature. That was a very big job because there were a lot of literature available. And the sources of information were was extremely large. You should think that each medical organization has its own guidance on AI ethics. Okay, so even if there is a lot of overlap, that there's a lot of options to look at, this might be because of an ethics washing effect. That's just an idea, but it might happen because there are it happened that some institutions are doing a lot of advertisement, and it's necessary that everyone says, look, I have a guideline, an ethics guideline in place. But then we found that the implementation of this is a little bit poor, right? So in this work, we focus on a selection of papers. The first one was the World Health Organization 2021 guidance on the ethics and governance of artificial intelligence for health. Then we focus as well on a systematic review that was published in early 2023, and it's including an overview of 45 papers on ethical concerns and related strategies for applying AI in healthcare. And then we did extra search on ethics of AI in medicine and on the ethics of patient-centered medicine as well. And so from these sources of literature, we basically identify the AI ethical challenges. Secondly, we integrate these ethical challenges from the AI perspective with those from the patient-centered medicine perspective. Then we identified responsibility and liaison by human agent. For this, we simplified the human agent universe to clinicians, patients, and developers as the main agents that have an interaction with an AI system in medicine. We then interpreted this under the scope of the ethical pillars of medicine, as you will see in a minute. And then finally, we defined a framework for human-centered action to enable ethic AI in healthcare. And then we decided something a little bit ambitious, that was naming this framework. So I'm starting by the end, and I'm going to be showing how we named this, and then I will show what is under this umbrella, right? So we basically decided to call this fair modeling, and this will be a human-centered framework for an ethical AI in medicine. One minute. So by fair modeling, we wanted to mean a practice by which all human agents involved in the development, implementation, and use of AI models in medicine, this being clinicians and healthcare workers that are to be interacting with the system, patients and developers mainly, are aware of the AI-related ethical risks and act to ensure that the AI system works towards the benefit of all humans. Okay, this is just an example of extracted data from our literature search for you to see how we define this fair modeling framework. We worked with the World Health Organization 6 principles on the ethics of AI in medicine. We also included the 12 principles that have been extracted from the systematic review. I mentioned it before. And then we selected main ideas from the patient-centered perspective and literature search. Then we defined the 5 facts for fair modeling action that are as follows. The first fact would be having knowledge and respect for the 4 ethical pillars of the medical profession. The second would be the prevalence of the clinician's knowledge. The third would be the respect for the clinician's decision. The fourth would be the empowerment of patients. And the fifth would be the developer's awareness. You will see now how we collected and in some way we organized all the information under these 5 facts. So why we decided to put in first place the knowledge and respect for the 4 ethical pillars of the medical profession? Well, and in the other words that we have been reviewing to build our facts, and we found that the different pillars were just spread over different dimensions, or just mention 2 of them or 3 of them. Well, we decided that if this has been the standard theoretical framework to assess ethical situations in medicine so far, because this has been the main pillar, that they have really strongly influenced ethical assessment in healthcare, that should be in place now as well. And they should be adapted to the AI, let's say, AI scenario now. What are the 4 pillars? The first is the respect for autonomy, the second is the beneficence, third is non-maleficence, and the fourth is justice. And the great thing of them is that they can be applied to any situation. So actually, the other 4 facts in our framework are to be interpreted under the scope of these 4 pillars, right? So there is some overlap here, because these 4 pillars are really interesting to interpret and to understand the ethical dilemma and the ethical risk of any situation. So the other 4 pillars will depend on the other 4 points, will depend on this first one. So the respect for autonomy is the patient autonomy. Patient autonomy should be maximized in informed medical decisions. Okay, so in summary, importantly, patients are autonomous agents, and they are entitled to hold their own viewpoints, are free to make choices, and act voluntarily according to their values, beliefs, and preferences. Second is the second pillar is the beneficence. Beneficence is basically the idea of doing good. Okay, so agents that are involved from patients' healthcare should act in a patient's best interest. So this is important, and this is including moral obligation. It has a strong connotation of doing good to others. The third pillar of the medical profession we should take into account is non-maleficence. So by non-maleficence, it can be summarized with do no harm, right? So patients should be treated as ends in themselves. And this principle is basically an obligation not to inflict harm on others. And the fourth pillar is justice, which is extremely important. It says that the medical benefits should be distributed fairly. This is a concept that is emphasizing fairness, equality, and also equity among individuals. So in summary, clinicians, patients, developers must be aware of the principle, and they all should facilitate that any medical decision is made accordingly to these ethical principles of respect for autonomy, beneficence, non-maleficence, and justice. Our second point was about the prevalence of clinicians' knowledge. So how clinicians build their knowledge? So as they practice, right, by expertise. So clinicians should be still able and free to develop their clinical judgment. Okay, the thing is that novice clinicians might become too dependent on AI recommendations when AI recommendations or AI systems are in place. And they might be at risk of not growing their own clinical judgment. So there will be at risk of disempowerment of clinicians. Especially for those cases that they fear they'll not be able to find a solution, right? The ethical principle says that doctors should make use of all their available knowledge and skills to make a clinical decision. And historically, when we talk about the knowledge from doctors, this is including explicit knowledge and tacit knowledge. By explicit knowledge is that knowledge that the clinicians have, because this knowledge is in books in some way. So it's knowledge that can be codified and can be written. These are skills that can be taught to another, right? Something that can be transferred. AI knowledge is included, and I think that the AI knowledge that is being provided by a system can be considered explicit knowledge and should be taken into account to make a clinical decision, of course. But there's also this tacit knowledge. Tacit knowledge is this very human knowledge, which is the kind of knowledge that we have, but that we do not know how to explain, right? It's the phone. So if someone, okay, with the microphone, please shut. If you can mute the microphones, please. Thank you. Oh, sorry. I just got my headphone. Okay, I'm back. So the tacit knowledge is basically, as I was saying, it's like a form of unconscious expertise. I'm sure that you have experienced this before. It's like maybe like biking, something that you cannot explain, but you know how to do it, right? Well, in medicine, this has a place as well. So doctors use their medical intuition. This is not any intuition, it's informed medical intuition, informed by the huge expertise, particularly very often used by expert clinicians. So the idea is that clinicians' knowledge should be in place, should not be replaced, but complemented by automatically deployed AI recommendations as part of the explicit knowledge that clinicians use to make the decisions. The third point is about the respect for clinicians' decision. So the clinician is the human agent behind the decision, right? Clinicians should incorporate the AI-based recommendations, but they should do this at their own discretion, but always aiming for the beneficence principle of acting in patients' best interest. So clinicians should respect their own decisions, even if these are contrary to the AI suggestion. If there is a conflict, let's say, if the clinician has the one opinion, so for example, giving that this treatment, but the machine is recommending another treatment. So clinicians should respect their own decisions. A clinician, because of the principle of freedom of action, clinicians should never be forced to act against their own beliefs. However, clinicians might be in a situation they might like to consult with other clinicians, as when there is a difficult case and a clinician has adapts on how to proceed with the case. However, the physician also has the moral obligation of caring for and having a deeper knowledge of themselves. And this is useful as they can identify their need to acquire further knowledge, in particular about the AI system. So they should respect their own decisions, but they also have the moral obligation of caring for their own knowledge, in particularly if we are in starting an AI era. So basically, clinicians understand how algorithms deploy the medical suggestions and how thoroughly they are validated and trained. I think that it will be much easier and they will be more able to establish trust towards the outputs and probably ultimately incorporate such information in their final decisions. This according to the principles of the beneficence and justice, because don't forget that it might happen that the system is understanding better the case or is giving a solution that can improve the health of the patient, particularly given in situations when we are prescribing drugs just using trial and error. So clinicians as a human competent agent are responsible of their clinical decisions and their decision must be respected. The fourth point is about the empowerment of patients. So the subjective patient experience, so I'm splitting this in two parts. The empowerment of patients. One is about talking the subjective patient experience. So it has been longly and extensively reported that including the subjective patient experience is key to achieve good treatment response. So the World Health Organization defined health like a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity, right? So this is really close to the biopsychosocial model of disease, actually, that was introduced by Engel in the late 70s. But the truth is that the model that has been imperative during the last, let's say, 20 years of medical practice hasn't been the biopsychosocial model. It has been the biomedical model. And AI algorithms are based on that model. Because of the biomedical model, for the biomedical model, patients are mechanical systems made up of interacting parts. This is known to be leading to objectification and mechanization of humans, and that is a big risk of dehumanization in medicine by using this model. Actually, this will be in breach with the non-maleficence ethical principle, and AI algorithms are following this model. And so far, there are big efforts for this, and there is a big effort to create this human-centered and machine learning methodology. But still, for AI algorithms, it's very hard to incorporate subjective patients' experience in the whole. Also, the evidence-based medicine also said that the unique preferences, concerns, and expectations that each patient is bringing to a clinical encounter must be integrated into clinical decisions if they are to serve the patient. So this idea of the subjective experience being necessary. It's everywhere, and the thing that the algorithms can incorporate them is still hard to see. The idea is that not chatbots or ChatGPT should be constantly replacing humans. Really, only humans have consciousness about the situation, have empathy with the patient, can know the context environment of the patient. These are known to be essential factors for the global moral imperative of the medical profession that says that each patient must be treated as a person. And this is in line with the beneficence principle. So in summary of this first part for the empowerment of patients is that giving the patient the chance and time to elaborate about their suffering should be part of any doctor visit. And this should happen regardless of the assistance of any AI tool. Second part about the empowerment of patients, it's about considering patients active agents. I mean, patients are not just entities waiting for a diagnose, right, or a treatment. They should be considered responsible agents as well. And this should be done in benefit of the respect for autonomy principle. Patients are active. They decide if having a treatment as prescribed. I mean, obviously, when I talk about patients, it's all of us, right? Because we are patients at some point in our life, all of us. So we decide if having a treatment as prescribed, we decide if attending a visit, we decide if doing diet or exercising. So patients are active agents, and the decision-making should be shared between patients and clinicians under a patient-centered perspective. Obviously, clinicians should support patients by turning raw data into information that is easy to be digested and interpreted by patients, because that's a hard task. Obviously, it's not easy to understand. They are not doctors, but they should be part. So the information should be made available for them in a way that they can understand. Also, patients should be informed about an AI system making decisions on their health. This should be done in benefit of the respect for autonomy principle, and also because they have the right to say, no, I don't want the system to be making a decision on me. They have the right under the UK GDPR Article 22 not to be subject to automated decision making, particularly when the outcome is having a significant effect on them, right? Because they are, of course, subject to automated decision making in many other areas, and like any social media or Amazon, right, in a daily basis. Also, the European law is saying that patients' perspective on data sharing, consent, and data privacy should be taken into account in healthcare and research. AI should guarantee the user's identity, data security, and privacy to be able to be in place. And also, again, about patients being considered active agents, patients should take part in what is called patients and public involvement activities. These activities will allow them to understand how AI models work, would facilitate inclusion of their point of views, their experiences, and their hopes and fears. But these PPI activities should be promoted, and patients should know that they exist, obviously. So clinicians should promote these activities and should recommend the involvement of patients. So to make them aware about this AI algorithm being in place, how it works, this all in search of the respect for autonomy. Finally, the last point is about developers, and we have called this developers awareness. So talking about responsibility, we have seen that clinicians have responsibility, that patients have responsibility, and the third actor here, that are the developers, also hold ethical responsibility on the AI performance. AI systems cannot be claimed about the outcome that they produce. They cannot be responsible of medical decisions because basically no AI algorithm could demonstrate consciousness so far. Of course, yes, if you have used ChatGPT, you have done. ChatGPT can simulate an apparent conscious behavior, and in a very closely similar to the human conversational way. But as you know, this is not spontaneous or intelligent behavior. This is just a task that the system learned from a lot of data and just extracted some existing patterns, and it's absolutely performed in an unconscious manner. So university departments, health tech companies should implement and use protocols so that they can ensure that they produce transparent models that can produce fair and non-discriminant outputs, all of this in search of the beneficence and justice ethical principles. So we cannot need to understand what means bias, what means discriminatory models, and what means that a model is transparent. So bias can arise with models that have been created, that have been trained in samples that were not diverse enough. So samples that, for example, had some groups, particular groups of people that were underrepresented. This we will see now an example that clarifies the concept. Because bias can be the cause of building discriminatory models. Let's see what that means. A discriminatory model is a model that is not fair and doesn't respect equity. So we should avoid discrimination and ensure that everybody gets what they need, because this is central to what we call patient protection. Okay? So AI system can be discriminatory against a particular group of people, for example, an ethnic origin, a group, a particular gender, a particular age group, religion, or belief, or other indicators. As an example, for example, you can see that I can show that a widely used machine learning algorithm was assigning the same level of disease risk to Black and white patients, even if Black patients were actually sicker than white patients. So the system was actually actively causing harm to these Black patients because they were allocating them to fewer resources. Okay, so this was totally in breach with the non-maleficence and the justice principle. So why happened this? Because the algorithm was trained in a sample that has no represented the Black ethnicity appropriately. Okay, so the sample size was not, well, the sample selection had this bias. So there were more white people represented than Black people. So the algorithm was not learning accurately about the outcomes about the Black people. Okay. Another thing that could be considered for building non-discriminatory models would be to exclude the political critical variables like race, gender, origin, or language. But there are many risks on this as well. There might be that there are other proxy variables, that even if you exclude gender, the gender practice is still in the model, and it might happen also that you can have a loss in accuracy doing this. The last point on the factors would be the transparency. Transparency in a model is opposite to the black box models. Black box models are models that we don't quite understand how they derive outputs. So the patterns that the algorithm follows are opaque, even to the person and even to the expert developer. This should be avoided, the use of these algorithms, because this is in danger of breaching the respect for autonomy, and there is a risk of disempowerment of those patients and clinicians. So developers should definitely consider explainable AI tools, that this will allow humans to understand the reasoning behind AI decisions and increasing intelligibility. And just for finishing, developers should promote sustainability. So of course, an algorithm needs to be updated as more data is available, gathered. So they should be regularly updating the tools or adjust them if they start to seem ineffective, or maybe there is a loss on accuracy. I think it's also ethical to implore that developers have a thorough comprehension and mastery of the methodology to develop consistent AI algorithms. I think that methodological limitations need to be well assessed and mentioned, such as small sample size, possibility of bias, failure to rigorously validate AI programs on fully independent samples. Some of these commercial tools that doesn't have a publication. So it's very difficult, for example, to check how what were the limitations. And also, those developing AI tools are prompted to follow the many guidelines, obviously, that are available on good practice in AI models. So these are the 5 facts for a fair modeling that we wanted to present. Just one consideration, we have been thinking a lot about the term fair modeling, because when we talk about modeling, it seems that we are talking about the development stage only. And it seems that it's very related with algorithmic fairness. But we wanted this to be a much broader umbrella, The idea is that everyone should contribute to the modeling. So this is why we call it fair modeling. So a clinician is contributing to fair modeling. It is making AI information interpretable. It is promoting PPI activities. It is alerting of inaccurate or discriminatory predictions. Patients can contribute to fair modeling if they take active, if they are taking active part actively on research, if they are proactive in understanding health decisions, if they are active in claiming for their rights about AI decisions. And also developers obviously can contribute to fair modeling by generating good, and the broader good term that you can imagine, good models, and facilitate their understanding and integration. I started with many questions. I think that I already pointed to some answers here. We can come back to here in the discussion if you want, but I think that these were not. I couldn't promise I could give answers to all the questions, but I think that I was at least able to give a suggestion of answer. And just for finishing a bit of discussion, I think that AI systems and humans are cohabiting since years ago, and this became more evident recently. I think that AI should work for the benefit of all, and obviously all humans should behave ethically. So in principle, there should not be any need to promote a fair modeling practice. However, I think that AI is so new in the society that it might totally happen, and it's happening, that people are not totally aware of the challenges behind. So work like the presented here, I think that in great need. We have introduced 5 facts for a human-centered ethic AI in medicine. They can be used in conjunction with the rest of the guidelines, obviously, but if you have seen our framework, it's specifically defined under human agents. It's not just naming challenges that you don't know who are responsible of, or that who can be proactive to help avoiding this risk. So the idea is that each of the facts is involving a human, and that is patient-centered perspective as well. So the idea was to help clarify who was the agent, who was the recipient, and who may take moral action. I think that this can help clarify a little bit the ethical action to be taken. And as a conclusions, I've been analyzing data since my PhD, that was like 2005, I think. And one question that always came to my mind was, what was the person in AI-based personalized medicine? So where's the person? Because my databases didn't talk, right? And a person is not just made of data. I think that there is a need to bring back the human to the artificial, as the exhibition where I am now is telling. And I think that ethics is one of the ways. AI complements human intelligence, but human intelligence also complements and creates actually AI. And a human is necessary throughout the whole AI pipeline. So this is why I think that there is a need to define the ethical frameworks. There is a need so that the ethical frameworks are available to all humans. We need to actively involve clinicians and patients in the AI process. And I think it's important to identify the role and the ethical responsibility that each human has. And particularly, this can help foster moral action and ultimately enable an ethical AI in medicine. So thank you so much. I'm going to end the show. If you have any question, please just tell me.
Yes, thanks a lot, Raquel, for this really exciting, interesting presentation. Yeah, are there any questions? There are a couple of questions in the chat, but I think that, for example, Costas, I don't know if you want to ask it by yourself, Costas, but Costas asked, in practical terms, do you expect AI fair modeling in AI applications development to run along 2 speeds, for example, become standard practice in fair AI development for countries with higher GDP and more mature health ecosystems versus countries with less resources? Would it mirror, for example, today's state of global availability, advanced interventions, and therapeutics?
Let me see if again a question, please. Yeah. Unfortunately, this may happen even if all those working on AI technologies are actually claiming the other way around, are claiming that AI technologies should be very interesting to be applied particularly in less developed countries, because there are less resources on the rest of the medical healthcare systems, and the implementations of the AI technologies should be advancing the healthcare system further. But the truth is that this is still to be seen that this is happening, because what we have seen before is that they are benefiting of these advances much later than Europe or US. So I think that, yes, I would probably agree with you with your comment. And the second question, would it mirror, for example, today's state of, yeah, this is exactly what I said now. Yep. Second question. So this is talking about my thoughts on approaches to reduce bias. Yeah. Well, this is, of course, in the data designing, and we need to make, so I think that we need to be proactive. So for example, in genetics, of course, we have seen many studies being done on white people, on white ethnicity, and not that much on Black people, but this is changing, right? So we were aware of this, and we are trying to incorporate these variables. So the idea is that developers, but also clinicians and patients are proactive on this, on claiming that these samples need to be diverse. If not, the only thing that these models, at the end of the day, are not being used. So it is very clear. It's just to build samples that are more representative. And I think that is effort from the different nations that are involved, and mainly from developers. We are very aware of the data that we have when we build a model. The problem here is that sometimes we don't have what is the variable that can be causing this bias. And it's afterwards that we know that there has been this problem, and we need to mitigate this as soon as possible. So I think that that's also one problem, because there are variables that are like very well known, but there might be other proxies or the variables that we are not aware of, and that are causing some bias that we are not aware of.
Hand up from Teru. Teru, you want to ask your question before we go back to the chat?
Yes, please.
Hi, thank you for a great talk. Thank you. I was thinking about something because we're doing this in Turing Roche Knowledge Share from the Alan Turing. So we're looking at patient outcome heterogeneity. And when I was thinking about the ethical talk and biases, especially the biases arising from the models, but we also know that unfortunately our human brains are also exposed to various biases. So in terms of ethical debate over this kind of problematic situation, is there any discussion over this? So how do we actually evaluate in ethical terms whether the human brain, so let's say a clinician is afraid of the change, and with the anxiety is prone to then contribute to further biases? So is there any discussion about this?
So when you say any discussion, you mean something that has been published on this or something? Well, I think that the discussions here, and you're right, I was also thinking a lot on this, because we are talking about bias from the programs, right? But there is a cognitive bias on us as well. And there's probably also gender bias and race bias that is performed by humans, not just by machines. Side. So in this sense, actually, if the model is well trained on a very diverse data, as it should be, it should represent less bias than a human, because there is not consciousness and there is not prior idea on of prior perception. For the algorithm, this is something blind. It's just a variable with two categories. So the algorithm doesn't know that this is bias or this is whatever other variable that has not these implications, right? And so there's no conscious idea on the idea of ethnicity or or differences or equality. So in some sense, this algorithm should be helping to mitigate the bias. But for this variable. So I think that this is a nice idea that reverse the idea that the algorithm is always bad. It's always going to be making biases. Well, humans are also making bias. This has been reported, right? So we know that. So the opposite idea could be to expect the algorithm to be helping the human to reduce this discrimination that sometimes occurs. I don't know if this helps you, but of course there are many on that. I could send you nice references on this.
Okay, thank you so much. Thank you.
Okay.
You're welcome.
There are plenty of other questions in the chat. So I ask now, Elizabeth asked another interesting question. Do you know of any research that is looking into whether PPI actually helps to increase transparency and trust in AI systems?
Yeah. Well, not about PPI. So what this published is about the effect of doing a patient-centered approach, but not particularly on AI, because this is so new. As I said, the thing we are doing something very prospective. We are doing something very proactive, very preliminary, because actually the systems that are being in place are few of them for clinical routine. So for clinical routines, it means that the doctor has the machine with the system there, and they can use it when you come into the doctor's office, right? This is not really happening yet. We're not yet there. I think that we will get there, but we are still in the situation that these systems are starting to be used. So we are starting to looking at this proactively, right? So I think that it's a little bit early to say that, but what we have seen, and this is why we were recommending this, is that the patient-centered approach is a key health factor for quality healthcare. And so this is absolutely patient-centered. So the idea of patient-centered is that the medical decisions are shared between clinicians and patients. So if clinician is using the AI system, it's like considering that this is another source of information for the clinician. So it's just like taking this idea of that the decision should be shared, and that this is augmenting even the feeling of the patient that things are going well with their medical care system for him, and that they are feeling well. So the idea to incorporate the patient on with the clinical and the AI system in the medical decision comes from the patient-centered. This is heavily and longly reported, and even acknowledged by the World Health Organization in its policy. So I think that what we are saying by this is just like taking an extension of this idea and applying this to the newest scenario where the clinician is also using the AI system. But in some ways, it should still benefit the patient, that the patient is incorporated. In one way to patient is by using PPI activity. I don't know of a single publication on this. If someone does, please, would be very nice to have the reference. Thank you.
Okay, there's several other questions we already over time, but Daniel Priel asked, should you favor explainable AI to protect anonymity at the cost of having not such powerful black box AI methods? So
I understand.
Yeah.
The question. So the idea, Daniel, is not to move to explainable AI. No. I'm telling that explainable AI are a set of very recent tools that allow to understand the rationale that algorithms use. But by using the black box algorithm, it's not that we are not using the black box algorithm, but there's like external tools that allow us to understand the patterns that this was not be able before, right? So these are tools that allow us to understand better how the black box algorithm works. So I'm not saying I agree with you. Sometimes there is a loss in accuracy if we replace a deep learning algorithm by a random forest, right? So that's not really the idea. The idea is that we use external tools to try to understand why the deep learning algorithm or the black box algorithm worked like that. Okay, so that would be the idea, to introduce these novel technologies that are called explainable AI to try to understand why the model did this estimation or this prediction and not another.
Okay, another question about synthetic data by Carrie.
Yeah.
You think that synthetic data could help create fairer models, especially when there are gaps in historic data for certain groups of people?
Well, I think that synthetic data can be always useful to run prototypes, right? We have done this before. And I think that if well created, this shouldn't be a problem, of course. But synthetic data is synthetic data, so there might be a problem of data not being representative of our population. And so we might be introducing some bias in our analysis. So we should be very careful on this. But we could use synthetic data, but always being certain that this is representative of the population, the characteristics that you simulate. Okay, I'm sorry I'm being a little bit short in the answers, but I'm seeing that there are so many questions and we are already running out of time, right?
Yeah. Another one is about a challenge to developer funded by commercial investors guarding their proprietary models and fear of losing IP.
Yeah. This is what we were talking about, optimism or even misbehavior. I think that there is a challenge. There is really a challenge here, but yeah, developers should act ethically and companies as well. This is why we are giving this talk today, and they should be aware of the very responsibility they have on the outcomes that they produce.
Then it's Robert.
For the question for Robert. Okay, so I think that it would be appropriate to give a patient a demographic summary of the data set. Wow, haven't thought about that. I don't think it would break some confidentiality of data. I think not. Well, if the model has been published in an academic journal, you can give the patient everything, and you can give this, and you can give more information if they're happy. Of course, it will be difficult for the patient to understand the academic paper, but this could work for the patient to build trust, I think, in some way. So it's not just really giving the summary of the demographic, that seems a nice idea, but I think that you can provide as much information as you can. Always the model has been published. Many of those models have not been published openly because they belong to some tech companies, so we don't know the details. But I think it would be nice to give as much as possible information to the patient so they can build trust, and also to the clinician. Yeah. Okay, I think there is I think we have, okay, it's 4 minutes past 4. I think that maybe we can allow, what do you think, Daniel? One more question, maybe. There's some with the one with that is raising their hand, and maybe we can finish then.
There's still, at the top, Maria's question.
And
to be honest, I'm not sure if that's relevant. Yeah.
Okay. And there's another lefty hand, or is a real hand? Sorry, Taru. It's a hand from Taru Sorza, I think.
Yeah.
Sorry, it was the previous one. Sorry about the confusion.
Okay, that's fine then. No worries, it's fine. Okay, then I think there are no more questions.
Okay, yeah, I think we're already 4:05. So thanks a lot, Raquel, for this really interesting and stimulating talk. I think we all learned a lot today, and we all have to think now when we start our next project or finish our old projects. So thanks again. I don't know, when is the next meeting, Raquel?
Okay, so I'm the organizer again. So
yes, now you're back to the organizer.
So for June, we are going to be moving our talk. It's not going to be on the last Wednesday, but this time we are going to having it on the 7th of June because of the speaker's needs. So we will be here very soon again on the 7th of June for the new talk. You can actually say the speaker, Daniel. It will be. We have Nico with that on.
Yeah.
On the 7th of June.
Yeah. It will be Nico Kutsoleris who will talk, but I don't know what he will talk about, but we invited him, so he, but I'm pretty sure
it will be interesting for sure. So
yeah, it will be very
on
interesting.
7th June from 3 to 4, we have, we will have the next talk. So thanks very much, everyone. And please come along to the exhibition at the Bush House today, and for the opening of the King's Festival of Artificial Intelligence, just starting today. Thanks very much to everyone.
I will leave in half an hour, so I hope to see you then.
See you. I'll be here giving a demonstration now, so 4 to 6. Come along. Thank you very much.
Okay, bye, everybody.
Bye-bye.